We're here at Winspace, the manufacturing part of their business, and this is the refrigerator where they keep all their Toray carbon. So when the carbon arrives from Japan, it's really important that it's kept in a really controlled state. So this refrigerator keeps it in a really well cold state, and also keeps the humidity in a really controlled way. Therefore, we have a lot of consistency in the material when we need it. The machine here is a vacuum table, and it actually sucks the carbon fiber onto the table so that it's secure. And that way, the cutter will cut each individual shape of the carbon fiber according to a layup schedule so that it can be used in the future for each frame. So this software here is a nesting tool, and the nesting tool basically puts each shape in the most efficient way so there's the least amount of wastage. So you see all these different shapes are placed on here, and it's cut on that table so that there's a minimum amount of wastage. So it's a very efficient way to use the carbon fiber. Here, the rolls of Toray carbon fiber is laid out on this table, and it's cut at a specific angle to allow the different layers to be bonded together. So by adding the different plies together, you can get the different stiffness that you want for each frame. So this is an example of the M6 mandrel, which goes inside the frame during the molding process. So every single frame actually has one of these inside, and allows us to really control the wall thickness of the molding process. As you can see here, this is the bladder that's inside the actual mandrel that's used for providing the pressure to create the compression inside the mold during the curing process. So after each piece of carbon fiber is laid out onto the mandrel in a very specific way, you can see all the different pieces of carbon fiber. Typically on most frames, we have about 300 pieces of carbon fiber, which is placed onto the mold. And these sections here allows the connection of the compression hoses to provide the pressure during the molding process. These frames here are actually waiting to be in the queue for the molding process. This is a piece of the M60 carbon fiber from Toray. It's a material that's actually relatively brittle, so it's really important that we use it in a very specific way. And generally, we only use this in the bottom bracket, the head tube, and the down tube areas where we want stiffness and weight reduction. So this is a small piece of a T700 carbon fiber from Toray, and you can see that actually it's much more flexible than the M60. So it doesn't have that same brittle quality about it. And actually, if you look at the details, there's a lot of little holes inside each piece of the carbon fiber, and this allows the air to escape during the molding process. And it's super important that during the molding, that all the air escapes from the mold, so there's no air trapped inside the frame. And this actually allows this to all be very efficient and escape. This is the M60, so you can see it's a much more brittle material, and it's cracking. These materials will have different properties and will be used in the frame in very different ways. So the machine here is a vacuum machine, which allows all the compressed air inside to be removed from inside the frame. Pressing these two buttons here, it turns on the vacuum and sucks all the air out of the frame before the molding process. This is what a frame looks like when it comes out of the mold. As you can see, the process of molding it is an incredibly detailed process with many moving parts built into the mold. A lot of the R&D and expertise really comes from the mold making and the mold design. So this is where the magic happens. These machines here allows a frame to be molded, and typically takes about 1 hour to mold each frame, which includes actually putting the carbon fiber frame around the mandrels inside the mold, preparing the mold, putting it into the heated press and letting it heat up and cure, and then extraction. So the whole process is about 1 hour. So there's only so many frames they can make each day. The new M6 fork, and what this machine is doing is actually testing the stiffness to see if there's any flaws within the actual carbon fiber structure. So here what they're doing is applying up to 800 newtons of pressure in both directions. And that line there is actually showing the deflection as they're applying the pressure. They'll be able to see if there's any defects by looking at that curve to see if there's any changes. If that line starts to dip, it actually means that there's a defect in that fork. This machine here is actually replicating a frontal impact of a frame. And this is one of the ISO standards that are required in order for a frame to be approved for production. What it does is it drops away from specific heights specified by ISO, but what we're doing here is actually 20% above the requirement, so that there's a bit of a margin for error. So the stiffer the frame is, and the better it is for the consumer, and it's more safe as well. So this is the M6 frame that we just X-rayed. So during the actual R&D process, we X-ray all the frames to ensure that the carbon fiber layup is properly done and that we don't have any defects within the layup. And this X-ray machine can show up all the smallest little details and some air bubbles and so forth. As you can see here on the actual X-ray image, you can see not only the fork, but also the frame. We will
actually do X-ray on every fork and every handlebar that we produce from this factory, ensuring that the frames and products that we ship are secure and safe. The Lund Hyper wheel is something that Winspace is very famous for. The use of carbon fiber was a real pioneering move that they made many years ago. And this machine here allows them to test the actual deflection of the rim after it's been built to make sure the alignment is absolutely perfect. So this machine here is testing the durability of the wheel set. Over a 32-day period, this will rotate up to 10,000 kilometers to ensure that there's a really stable and safe wheel set. The machine here is actually testing the torsion of the hub and the spoke assembly. By actually securing the hub in its location and providing friction where the tire is, it's actually creating a torsional force on the wheel set and testing the torsional strength of the wheel.